Okay, the next step in our force calculation or trust calculation is going to be to and I'm just erasing this so you've got each of these videos. We have to start working our internal forces. And so what we're going to do for these internal forces is we are going to see what is the information that we know, where do we want to go to work. Okay, so we're going to go back to our working trust and we're going to look at this. And so I've identified, I'm going to clean this up a little bit to make this a little bit better. So I know that RAY is 350 pounds. I know that RAX is 0 and RCY is 150 pounds. Okay, so what we want to do is we want to look at where do we have the most information to work from. So if I go to joint A, I have one vertical force that I know. I have one horizontal force that I know. I don't know this horizontal force, so I have one unknown here. And for this one, we would turn it in, but I do have a right triangle, so I've got 53.1 degrees. But I also need to figure out this here, which is going to be we'll call this, this is, all right, let's figure out the vector of this line. So this is AB, that's an unknown. For that one, I have to figure out AD, which is an unknown. And to figure out AB, I have to identify the ABX and I have to identify the ABY. Okay, so I've got one unknown, but I've got an angle, one unknown, 2, 3. So I've got some work to do here. If I go over to B, I have a lot of unknowns, and we're just going to kind of put this into a different color so you can see it. So I would have to find this unknown, which is, we're going to call this ABX. ABX. I'd have to find this ABY. I don't have a right triangle, so I don't have any angles there. I have to find this vector, which is our BD. I have to find this, which is our AB, which is also going to be the same here. So I have to find the AB there. I have to find this side, which is my BC. And then I would also need to find, to put this into a right triangle, I would need to find this BCX and this BCY. And I have no information. So I definitely am not going to start at B. B is a hot mess, okay? Because there's a lot of information that I am trying to get at B that I do not have. So we're going to leave B alone. C is very similar to A. So I've got my go up, but I would still need to find this. So I need to find this. We'll call this BCX vector. I would still need to find this. We'll call this our BCY vector. And then I need to find the BC here and then the DC here. But A and C are pretty much the same. So we could work either one of those. I know an angle. I've got distances. I've got formula. I've got a force going that way. So I could do C. C is doable. But we're not going to do C yet. So I'm just going to kind of erase some of this stuff out so that you guys can see what we've got here. I'm going to put this back in. So we're going to figure that out. We're going to figure that out. There it is. D is a great one. We talked about this as the Canberra with the big houses. I have one unknown, but I don't have enough information yet to get either of these verticals. So I have an unknown horizontal, and an unknown vertical, but I do have a vertical that I do know. D is going to be our sweet spot, super easy when we get down there. But what we need to do is figure out where we're going to start. I'm going to start at A. And you could certainly start at B if you wanted, or C if you wanted to. But we're going to leave B and D alone. B is a mess. We don't want anything with B. So now we're going in and we're going to start to solve our internal forces for each of our problems. So the first thing that we're going to do, so this is going to be our next step, is to solve our internal forces. We're going to pick our joint and make a free body diagram. So I am going to do this in purple. So we'll do all this in purple. So I have joint A. What is everything that I know about joint A? I know that I have a 350 pounds going in the upward direction. So we've already solved for that one. I know that I have 0 pounds going in that direction there. I need to find AD. So this I need to find AD vector. I need to find my AB vector. So I'm making a free body diagram. So this is my AB line that I need to find. And in order to find that AB, I need to find, and I'm going to put this in a different color just so you can see what we have to find. I have to find this, which was going to be our ABX vector, and our ABY vector. So those are the things that I need to find. Now I do have this interior angle of 53.1. Okay, so that's my interior angle of 53.1. So we are going to solve for this. So I'm going to mark this off here. So this is going to be, so you know where we're at. So we're going to solve for joint A. That is everything we know about joint A. So we are going to do, there's a couple things we talked about. So the alternate interior angles rule states that if we have two parallel lines, so here's a parallel, that's cut by a transversal, the opposite angles are the same. So that means that this angle here also has to be 53.1 because of the rule of alternate interior angles. So we know this angle is 53.1. This is the opposite alternate interior angle has to be 53.1. So I've got a lot of great information here. So the first thing we're going to do is we're going to sum our forces, and I'm going to do it in the y direction because that seems to be pretty easy for what we're going to do. So my sum of my forces in the y direction all has to equal to 0. So I have 350 pounds, which is going up, 350 pounds, and that's going to be my first one, plus my other y direction that I have is I did these wrong. This is my x direction, so that's ABX. This is my y direction, that's ABY. So then I have my ABY plus ABY vector has to equal to 0. Okay, and so what we have done is I have assumed that AB it's going up, so I drew the arrow, so that's going to be a positive number. So we're saying AB, we're going to isolate it. So vector ABY is going to be equal to negative 350 pounds. Okay, now here's a couple things that we've got. One, we are on our model, we assumed that our force was in tension, which means the reaction force would be compression, which would be going up and to the right. When we get a negative number, we're saying no, that it is actually going down and to the left. So our assumption with the method of joints was not accurate, but we are not going to change anything until we get to the end of it. So now I know that this, my ABY, is a negative 350 pounds. Okay, so that is going to be what we're going to get. So now what I need to do is I want to find this vector of angle, this AB. This is what I really need to find. So this is what I'm trying to find here for our AB. So in order to find this, we're going to go back to our SOHCAHTOA. So I have my sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. Tangent is equal to the opposite over the adjacent. What we're going to do is I'm going to use the sine. So what I've got here is I've got this one here. I do not know the hypotenuse, so I'm trying to solve for the hypotenuse. So this is my hypotenuse, but I've got my right triangle here. So I know that this is my opposite. This is my adjacent. So I'm going to do the sine of my angle 53 degrees. Sine of 53.1 is equal to my opposite, which is, this is my opposite, and here's my adjacent. My opposite is negative 350 pounds, negative 350 pounds over, and I'm going to do my hypotenuse, AB vector. So there's my hypotenuse. So what we are going to do is we're going to say that I'm going to isolate this. So I'm going to multiply by AB. So AB vector is equal to negative 350. Let me do this a little bit better for you guys. Oh, let's get this a little bit better. Okay, so what we're going to do is I'm going to put my AB vector times the sine of 53.1, right, is equal to negative 350. So I need to isolate this. So my AB vector is equal to negative 350 divided by the sine of 53.1. Okay, so and I'm going to put this in here. So what I'm going to do is go to our calculator and we're going to solve that. So let's go to our calculator here. So we are going to do negative 350. So negative 350. Oh, I'm going to clear this out. I don't want my answer. So I'm going to, negative 350 divided by the sine of 53.1 degrees is equal to 437.672. So we're going to round up 437.7. And that makes sense because it is a negative number. So my AB, my hypotenuse, is negative 437.7 pounds. So, and that makes sense because once you have a negative, you always have a negative. So that is 437.7 pounds is what we've got for AB. So I know that that's what I've got for AB. Okay, so now what we've got to do is we have to solve for this ABX so that we can get what AD is. So here's how we're going to do this. So I'm going to do the same thing. So this is my hypotenuse, my adjacent, and the opposite. What is it that I'm going to do? I know I'm trying to find this ABX, which is my opposite. So that's going to be my adjacent. I'm sorry, this is my adjacent angle. So I need to find my adjacent. I have the opposite. This is what I'm looking for. So what I'm going to do for that one is I'm going to use tangent. So I'm going to do tangent of 53.1 degrees is equal to, and that's going to be my opposite over my adjacent. So my opposite is that negative 350 pounds over my adjacent, which is going to be that vector ABX. So just like what we did over here, we're going to find, I'm going to move this down just a little bit so we can see this. So I'm going to isolate my ABX. So I'm going to multiply. So this is ABX times the tangent of 53.1 is equal to negative 350 pounds. Then I'm going to do ABX is equal to negative 350 pounds divided by the tangent of 53.1. So we're going to go into our calculator here, clear that out, and we're going to do negative 350 divided by the tangent 53.1 equals 262.8. Okay, so we're going to go back and we're going to put that in there. So ABX is equal to negative 262.8. Okay, and that makes sense because once you have a negative number, we always have a negative number. So what we are going to do here is now we're going to sum our forces. So we summed our vertical forces in the y direction. So that was the 350 plus our ABI. Now we can sum our forces in the x direction. So our x direction, we have my ABX, which we just found, which is negative 262.8 plus, and then I have my AD, which is right here that I don't know. AD vector is equal to 0. So we're going to isolate that. And so what we're going to say is AD vector is equal to 262.8 pounds. And that is a positive number. and that is our reaction force. And so this would be 262.8. And we are saying that, yes, this is correct in our assumptions, that we're saying that the reactionary force in tension is to pull, which is we're pulling back in. So 262.8 for our problem there. So we have everything that we need solved for A. So now what we're going to do is put that onto our summary truss. So we're going to go back up here to our summary truss, and this is where we're going to put this in here. And so what we are going to do for this is, and we can keep track of this as we're going, we know now that this one is in compression. So we're going to put a C in here that's in compression, and it's 262.8. And this one was incorrect. It was not in compression. It was, or not in tension. It was in compression. So in tension, our reaction is to pull in. So this one was wrong because we're assuming it was going this way. This is going down and going out. And so this one is going to be in tension. What did we say that was? That was 437. 437.7. 0.7 pounds. Okay, so that one we were incorrect. And so we're saying there's 437.7 pounds. We are done with joint A.